Hi everyone, today's Leetcode question called combination sum. So in this question, we'll find a combination integrated array that sum to a specific target. Let's check example one here. So example one, we have this array 2, 3, 6, 7, right, and target 7. So one way to add up to this 7 is to pick double 2 because here we are allowed to use the same number and 1, 3. So you see 2 plus 2 plus 3 exactly get this 7. And the other strategy is to pick the single 7, right? And we also reach the target. So the result array you see contain two subarrays, one is 2 to 3, and the other is 7. Okay, I think the problem description is quite straightforward. Now let's think about how to solve this problem. So if you watch my previous backtracking video, you will know for this the question including the combination, permutation, and subsets, I prefer the backtracking strategy, which is efficient and easy to understand. So again, let's consider how to use the backtracking strategy for this problem. So before recording this video, I have this example and how it works with backtracking strategy. Okay, so here let's use a graphical explanation. So starting at the current point as 1. Okay, let's say the current point is at 1. And you see here target is 3, right? So we want to deduct this target by the current point and to check the remaining target. So we go from here to here because we have deduct the 1 on the way. And the path should be go from here to here because we have append the 1 on the way, right? Let's say add 1. Okay. And now the target is still greater than 2, so we want to continue searching the remaining target, right? Okay. And here, let's keep the current point still at 1. So we want to further deduct target by 1, so get 1 here, and add the path by 1, so add another 1. That's why we get a 1, 1 here. Okay. And here the target is still greater or equal to 0, so we keep the current point here and search the next level. So next level, we keep deducting target by 1 to get 0, and append the path by 1 to get this 1, 1, 1. And here 0 is still greater or equal to 0, right? So I want to keep searching, keep this current point. But also, if target is 0, want to add this path to our result because it's a valid element. So let's use a different color. Okay, so we'll add this one to our result set. Okay, now let's traverse further down. So target 0 minus by 1. Again, minus 1 here. And you see, if we go this 1, 1, 1, we add another 1. We get this array containing 4, 1, right? And here from target, okay, is smaller than 0. This is what don't we want. And we just break this pathway and check the other pathway. Okay, so for the backtracking strategy, if we finish one pathway, we go back to the previous pathway, right? So we are going back to the previous pathway, and let's do different color. So I'll add here. And at this point, since we have previously used 1 here, the only thing we can use for the current point is 2, right? Okay, if select these 2, and our target should be changed from 0 to minus 2, right? Because we have deduct these 2. Okay, and the target change to minus 2, and the path should be changed from this 1, 1, 1 to this 1, 1, 1, 2, because we have add another to this path array. And if we do this one, this target is actually smaller than 0, and there's no way we can continue search, so we also break for this pathway. Now we have traversed all possibilities at this level. We want to go back to the previous level, right? So let's use a different color, and we're going back to this level. And at this level, since previously we have VT1, now can only check these 2 at the current point. And the target should be deducted by these 2, so it comes from 1 to minus 1, right? Okay, and the number should be 2. So this is 2. And the path should be changed from this 1, 1 to this 1, 1, 2, because we add another 2 to this element. Sorry for the messy drawing here. I hope you can understand. Okay, at this step also, if our target is smaller than 0, this is why I have to break out this pathway, right? Okay, now we have traversed all possibility at this level. Let's go back to the previous level at this step. So let's use again a different color. This okay, this red color here. Now we are at this level, right? I want to restack the current point from 1 to 2. In that case, we have to deduct target 2 by 2, right? So we're going from this step to this step. And the current now is 2. Then pathway should be changed from this one to this one too. Okay. And here we found this target is exactly 0. So this one too is what we want for the result. So add this one to our result array. Okay. And here, let's go further down since it's still greater or equal to 1. So you see, if we deduct this 0 by this 2, because 2 in the current point, we get this minus 2, and path should change from a 1, 2 to 1 to 2 because we add another 2. And this step, this minus 2 is smaller than 0, so we just break for this pathway. Okay, now we traverse all possibility at this red stairs. We want to go even back to the initial condition, this one too, right? So go back to initial condition, and let's reselect the current point at these two, so this gray one. Okay, if we select the current point at these two, we want to deduct the target 3 minus 2, right? So we get this target 1, and the current point is 2, and path should be changed from this empty array to these 2, right? Okay, and for this step, since 1 is still greater or equal to 0, we want to keep searching until the target is smaller than 0. So we deduct this one by these 2, so we get this minus 1. And the path should be add another 2, so we get 2, 2. And here we found, okay, this target is equal to minus 1, so it's smaller than 0. This is why we have to break out this pathway. Okay, till now we have find all possibilities starting at this step, right? And we have to finish our search. Okay, now let's clean the graphical explanation and go back to the coding step. Okay. So first thing, let's rename candidates to nouns so we are more familiar with nouns operations. And the other thing to initialize paths empty result, empty array, sorry, and the result and empty array also. And after that, let's call the helper function, pass in this noun, this target, this path, and this result. Okay, and finally return the result array in the main function is done. In our main function, next thing to check the helper function. So for the helper function, let's pass all these variables. And first thing to consider the helper function is to run the recursion, right? So for i range length nums, I want to call the helper function. And in helper function, nouns should be all nouns starting at I, because here we are allowed to reuse the same nouns. And target should be target minus numbers 1, because every step we deduct the target by the current number. So as the next step, we only have the remaining target. And for the path, we have to add the current noun. So add it here, nums add I, and result should be same. Okay, now finish the recursion. Let's think about how to address different scenario for target. So if target is smaller than 0, this means in previous step, target is minus numbers I is smaller than 0, right? And this means target is smaller than numbers I in the previous step. If that's the case, this means we have already exceeded the target limit and we cannot finish, so we have to return null. And otherwise, if target exactly 0, this means we have exactly finished this step, right? So means target is equal to number size at this step, and we want to append the path result, and it should be done. Okay, now let's submit the code to see it works. Okay, you think the time capacity and memory usage of this solution is not bad, right? And I think the code each understand is very similar to the previous framework like subsets and permutations. If you find this video helpful, please like this video, subscribe to my channel, and I see you next time. Thank you.